Okay, short video lesson on linear equations and solving linear equations. A linear equation shows us how x is related to numbers we know. Solving a linear equation is finding the value of x that makes it true. There will only be one value of x that makes it true. For example, here's a linear equation. It shows us how x is related to numbers we know. An equation will always have an equal sign, and an equation will only have one unknown or variable. Quite often it's x, doesn't have to be, it could be any letter. So our job is to find the value of x that makes that true, that makes it a true statement. And one way of doing that is there's several ways. One way of doing it is this so-called cover-up method. So if I cover up this with my finger, so what number, if you add 4 to it, makes 19. So there's only one number that can be under my finger. There's only one number, and that's 15. So the 3x must be worth 15. Now if I cover up the x part, if I cover up this, 3 lots of what? That means 3 lots of x. There's a multiplication sign between those two, which we understand to be there. So 3 lots of what is 15? And your brain will figure out that the only number that can be under that pen lid is 5. So x is 5. Some people would, another way to solve this equation would be to treat it as though it's like a pair of balances, that these two things are in balance. The equal sign tells us that these two things are in balance. So if this was a pair of balances, we want to keep it in balance. As long as whatever we do to one side, we also do to the other, then these two sides of the equation will remain in balance. So what some people would do at this point is subtract 4 from both sides. If you subtract 4 from both sides, you get down to this. And what some people would then do is divide both sides by 3. So if you take 3 lots of x and you divide that by 3, you just get 1 lot of x. If you divide that by 3, you get 5. So using the balances idea, that's another way to solve this equation. Here's another one. If you use the cover-up idea, if we cover up this, so what number, if you add 30 to it, gives 20, your brain will soon realize that the number under my finger has got to be negative. What negative number, if you add 30 to it, will give 20? You will figure out that that 2x must be negative 10. So because negative 10, if you add 30 to it, will give 20. Some people will subtract 30 from both sides. They'll subtract 30 from that side and from that side and get to that line. And then you have to ask yourself, 2 lots of what? 2 times what? 2 lots of what makes negative 10? Your brain will figure out that it has to be 5, but it has to be negative 5. 2 lots of negative 5 make negative 10. So x is negative 5. Alternatively, the other way to do it is to divide both sides by 2. So x is negative 5. With this one, the cover-up idea, what number, if you add 15 to it, will give you 20? So the only number that can be under my finger is 5. So 2x must be equal to 5. And then if you cover up the x, 2 lots of what is 5? 2 lots of what is 5? The only number that can be under the pen lid is 2.5. X must be 2.5 or 2.5. In this one's more awkward because x appears on both sides of the equation. So we can't use the cover-up idea straight away. There's something we have to do first. And we definitely need to treat this one as if it's a pair of balances in balance. So what I'm going to suggest is that we, if these were a pair of balances, that we take off and throw away 3x from this side and take off and throw away 3x from this side. So lift off and throw away 3x from that side and from that side. It doesn't matter what the value of the 3x is. As long as we take off and throw away the same thing from both sides, the balances will still be in balance. So if you take off 3x from both sides, that will take you down to there. Now you could use the balances idea or the cover-up idea. So the cover-up method would say what's the value of whatever it is under my finger, so that has to be 5, so 2x is 5, and then if I cover up that, 2 lots of what is 5. The only thing that can be under my finger is 2.5. Another example, in this case, again, we've got x on both sides, so for many people the priority would be just to have x on one side, so again, take away and take off and throw away 3x from that side and 3x from that side. That will take you to there. 3 lots of x have been taken off both sides and thrown away. Now, if I cover up this, what number, if you take away 15 from it, will leave you with 20? The only number that can be, value that can be under my finger is 35, so 2x is 35. And now if I cover up my finger, 2 times what is 35? 2 times what number, 2 lots of what is 35? 17 won't quite do it, that's not quite enough. 18 is a little bit too much, so it's between 17 and 18, it has to be 17.5. X has got to be 17.5. Another example, using the cover-up idea, 21 divided by what is 3? So what number goes into 21 3 times? What number goes into 21 3 times? X has got to be 7. This one here. 9 goes into what 3 times? 9 goes into what big number 3 times? The only number that can be there under my thumb is 27. X is 27. That will do. Thank you.